All right, so we're just going to do the first one, which is what we covered yesterday from 4.2, finding the inverse based on the points, and then finding the domain and range. So the relation consists of the following points and the segments drawn between them. Find the coordinates, domain, and range of the inverse. So I'm actually going to graph it down there on the bottom. So the original points would have been 0, 1, 3, 2, 4, 5, 6, 7, and 9, 8. So 7, 8, 9, 8. So original function should have looked like that. And then how do I find the inverse points? Just switch the x and the y's. Good. So the x's of the inverse would now be 1, 2, 5, 7, and 8. And the y's would be 0, 3, 4, 6, 9. So now if I graph that, 1, 0, 2, 3, 5, 4, 7, 6, and 8, 7, 8, 9. And my graph looks something like that. So again, if I had drawn the line through that y equals x, it should fold over it and overlap. Okay, but sometimes, most of the time, it's easier just to switch them. Who's right so far on their graphs and stuff? Okay, good. All right, so now you got to do domain and range. So domain of my initial function is what?
The initial one?
Yep, 0. Good, 0 to 9. So the x values go 0 to 9. And then the range?
1 to 8.
Good. 1 to 8. And then we just switch it for my inverse, right? So the range becomes the domain becomes the range. The domain is 1 less than or equal to x, which is less than or equal to 8. And the range, 0 less than or equal to y, which is less than or equal to 9. Easy stuff, right? Any questions on what we learned yesterday? Okay, so we're going to continue. All right, so the last one was the word problem. Okay, where you've got to come, well, it actually gives you the formula. So it says a thermometer gives a reading of 25 degrees Celsius. Use the formula, write the inverse of the function, then use it to find the equivalent temperature in Fahrenheit. So I'm just finding the inverse of this one, right? So if I switch it, I would make this F, this C, and then I want to solve for that new C. So how can I get rid of the 5/9? Good, multiply by the reciprocal. So if I multiply both sides by 9/5, it's going to cancel from here. I get 9/5 F equals C minus 32. And then add the 32. So what this is telling us is we've switched the F and the C. So if I take and plug Celsius into the F, I can get Fahrenheit with this. So if you want to write it that way, if you wanted to make it that this is really the inverse of my original function, which the inverse was C. Say that this is C -1 of x, so that you can kind of distinguish the difference between the two. Or keep it the way that it is, but make sure that when you're finding the temperature in F, that you are plugging into the actual F, which is now your C. So we've switched them. And it wants you to find the equivalent temperature of 25 degrees Celsius. So all we've basically done is taken this and solved for the Celsius instead. So I'm going to take that C and plug it in where the F is. So 95 times 25 plus 32 equals C. And then 5 goes into 25 5 times, 45 plus 32. And I'd get 77. So this 25 degrees Celsius is the same thing, 25 degrees Celsius is the same thing as 77 degrees Fahrenheit. So we switch the variables, which is why when we go to plug it back in, we can't plug it back into the same variable. So this type of question is not on your quiz. I don't want you to stress about it too much. I don't think it will be on your test. I haven't seen your test yet. But if there is, then we will go back over these again. Most likely you'll get ones like we just did. One where you've got the graph and you've got to switch it and find the domain and the range. And then one where you're given an equation and you want to find the inverse. Questions overall on 4.2. Okay, so 4.3. Okay, so 4.3 is the introduction to log functions, which is basically going to cover, like, the rest of the chapter will be a lot of log stuff. So your quiz on Tuesday is 4.1 to 4.3, so it's going to cover the stuff that's in this section. So again, the little number on the log goes across the equal sign and picks up the one that's by itself, making it its exponent, and then that log drops off, leaving the bigger number by itself. If I'm going to go in reverse order, 4 to the second equals 12, then I look at it that this is the base of the exponential function, so it becomes the base of the log, and then no pairing ever stays together. I said it's like a high school relationship. They just don't stay together. How many of you have a significant other no? See? They don't last. If you do, I'm sure it's not yours. Yours will make it, I'm sure. Okay? Most of them don't. But logs never do. Logs and exponentials, the pair never stays together. So if it starts as 4 to the second, the 4 and the 2 split. The 4 goes over and ends up with the 16, and the 2 goes to the other side of the equal sign. And then if I'm going from log to exponential, the 4 comes across the equal sign, picks up the 2, and leaves the 16 alone. So none of the pairing ever stays together. Okay? So the first do is just that. Go from exponential form to log form, and then we're going to go back the other way. So if I have 3 to the 5th equals 243, then I would write it as log. What's the base? 3, so the 3 goes to the bottom. The 243 comes across the equal sign because the 5 gets sent to the other side. Okay, 25, oh, that should be the square root. I lost the root. The square root of 25, which is really actually exponential form, would be 1/2. 25 to the 1/2 equals 5. So I would say log base, good, 25 of 5 equals 1/2. So 10 to the 4th equals 1,000 would be written as what?
Log 10 of 1,000 is equal to 4.
Good. Log 10 of 10,000 is equal to 4. 6 to the negative 1 equals 1/6.
Log 6 of 1/6 is equal to -1.
Good. Log 6 of 1/6 is equal to -1. And A to the B equals C.
Log A of C is equal to B.
Good. Questions? Raise your hand if you've got them all right. Okay, good, because you can't do that, then we can't keep going, right? Like, that's the basis of it. switch the other order. So now we're going from log, which I think is easier, log to exponential. Remember, the little guy comes across, picks up the exponent, and leaves the log by itself. So for this first one, this little 9 is going to come over and pick up the 1. 9 to the first equals 9. Good. The next one would be 2 to the 9th equals 512. Good. The next one? Good. Next one? Good. And the last one? Good. B to the 0 equals 1. Okay. And these are all true statements, right? They all have to be true in order to be in this format too. Okay. So you've mastered the first. That's the first thing you have to get past. And then the rest of it's not so bad. Okay. All right. So special properties of logs. A log is an exponent. So the rules for exponents also apply. Okay. If I had log base b of b equals 1, then the exponential form would be b to the first equals b, which is true, right? Which means that any log that has the same base as the large number, my result's going to be 1. So if I have just log base b of 3, log base 3 of 3, right? So the base is the same as the large number. What do I know that to be? If I asked you to just simplify it, so now you're giving me an actual value, what should go on the other side of the equal sign? 1. So if the base is the same as the large number, your simplification or your answer is always going to be 1. Does that make sense? Because you're saying, what power do I raise 3 to get 3? And it's to the first. Okay, the log of 1. So now if I have b, the base is b, on the other side is the 0, then the large number is 1. So the only way to get 1 out of a result of an exponential is if the exponent is 0. So now let's say I had log 3 of 1. So the question is, what do I have to raise 3 to get it to 1? And the only power you can raise to get 1 is 0. Okay, does that make sense? Yeah. So the other thing is, actually, I'll save it for when we get to the calculators, but you're going to start using calculators for logs with these a little bit. Not yet, but in a little bit. The common log, so the log with a base of 10 is called the common log. And if no base is written on a log, so if you just see the word log, then it implies that the base is 10. So if you look at a scientific calculator, or graphing calculator, whatever it is, you see a little button then that says log. That is saying log base 10. So the word log by itself means log base 10. So when I see log of 5, it's really log base 10 of 5. So we're going to do these without a calculator. You're going to do these using, they call it mental math, okay? So if you can't do it in your head, then set it up as an equation, get it into exponential format, and then figure it out. So if I don't know what power I have to raise 5 to get to 125, then I can kind of set it up this way if I have a hard time reading that. Set it equal to x, and then put it in exponential form. So the 5 comes across and picks up the x, so 5 to the x equals 125. And I'm basically saying, what power do I have to raise 5 to get to 125? Some of them are going to be easy and obvious. Do you know this one? 3. Some of them you might have to break that number down. So if I break down 125, if I don't know that it's 3, then I can do this is 5 and 25, and this is 5 and 5. And it would be a perfect root, otherwise it wouldn't give it to you. Okay? So 5 goes, there's 3 5s there, which means that this is really 3. Okay, gets a little trickier with decimals. So 0.01 is what fraction? If I read 0.01 out loud, what is it? It's 1 over 100, or 1/100th, right? So this is the same thing as saying log of 1 over 100th.
You said that you assume the base is 10?
Correct. If it's not there, it is 10. Yep. So this is saying 10 to what power gives me 1 over 100? Negative 2. Good. So the negative moves the 10 to the bottom. And then to get from 10 to 100, I'd have to raise it to the second power. So this is negative 2. The other way to look at it is if you remember decimals and negative powers, right? To get from 10 to 0.01, I have to move this decimal 2 places to the left. So if you've done scientific notation and I move to the left, moving to the left is a negative. So I've moved it 2 places to the left, which means -2. So whether you're comfortable with the fraction or the decimal, you stick with whichever one makes sense to you, okay? All right, and then the last one is log base 5 to the 1/5. So what power do I have to raise 5 to get it to be 1/5? -1. I need it to move to the bottom, but not change value. Questions on any of those? All right, inverses. So because logs are the inverses of exponents, the inverse of an exponential function, such as y equals, that should be 2 to the x. This is not a x, that should be an exponent. Is a log function such as y equals log base 2 of x. So these are inverse functions, which means you can switch the x's and the y's on these. So if I were to graph my initial exponential function, it would have looked like that. If I switch the x's and the y's, I get my log function, which looks like this. And the domain and the range for the log and the exponential functions are also switched. Last one. So first thing we have to do is actually set up the equation. This says to make tea, use 1/6 teaspoon of tea per ounce of water plus a teaspoon for the pot. Use the inverse to find the number of ounces of water needed if 7 teaspoons of tea are used. So we have to use the first pieces of information to actually set up an equation. So if we're doing 1/6 teaspoon per, God bless you, per ounce of water plus 1 teaspoon of water for the pot, okay, then I would have to do 1/6 per ounce of water. So we could say it's W, you could use whatever variable you want there. Plus 1 teaspoon that you would add into the pot. So this is going to equal my tea, okay? Now if I'm finding the inverse of that, I do the same thing we did before. I switch the variables, so this is W equals 1/6 T plus 1, and then subtract the 1. And how do I get 1/6 T to be just T? Good, multiply by 6 on both sides. So this is the inverse of that function. So if this was a t of x, this would be t negative 1 of x. And it says, use the inverse to find the number of ounces of water needed if 7 teaspoons of tea are used. So how much water do I need if 7 ounces of tea? Okay, so once we find the inverse, right? So we're saying that this is, not here, we're saying this is the inverse, which could have been 6w minus 6 equals t as well. Like we could have distributed that. But when it wants you to plug back in, we have literally swapped these variables. We have said the t is now the water and the water is now the t. So if it says to find the number of ounces of water needed if 7 teaspoons of tea are used, we actually have to plug that 7 in the place of the water. So I would do 6 times 7 minus 1 equals t. And then 6 times 6 equals t. And t equals 36. That makes much more sense. Okay, so typically when you're solving, you're fine. When we haven't switched the variables, but this time we actually said that the w became the t and the t became the w, which is why we need to switch it. Does that make sense? Yeah? Okay.